All right, let's get started. So thank you guys for being here. I know it's the last session, so we will, I'll try to go quick so you guys can get to happy hour. Um, so this presentation is just going to be about unleashing enterprise data and trusted AI with Cloudera on RKE2. So the presenters, I'll be your main presenter, and then I also have our Director of Engineering, Rahul, and our ML Product Manager, Chris, as well. Let's get this. So have you guys heard of Cloudera at all? Okay, so your knowledge of Cloudera might be the Hadoop days or just big data as a whole. We've built these microservices, so we've taken our existing data and analytics stack, and we've built microservices on top of them. So we have data engineering, data warehouse, and machine learning. So, what do you really get out of it? Before, you'd have platform admins dedicate specific hardware just as a whole to the entire cluster. And what we can do now is you can dedicate specific compute hardware for the right kind of workloads and streamline those dependencies. They're not static environments anymore. It's software-defined infrastructure, and they're ephemeral sessions that also can auto-scale as you need it. What do you get out of this platform? You get platform availability, SLA adherence. You have a lot of platform tenants, noisy neighbors, a lot of people competing for the same exact resources in a static environment. But if you size those environments properly in Kubernetes, those environments will spin up and spin down as you need it. And that's kind of what we're showing here. So you can see that as you need more compute, you can have the actual cluster spin up, scale up and scale down. So for hardware provisioning, you can see, as you need more hardware, it does go up and then it comes back down. So we've simplified multi-tenancy, simplified deployment of applications, and also a much better utilization of infrastructure. So meet SLAs with predictable performance, optimize cost and platform agility, deliver time to value, and enable hybrid portability. So what we've really done is in our original base cluster concept, and that's what Cloudera used to be about. It was a monolithic cluster. Storage and compute were not separated at all. It's all co-located. So if you needed more compute, you had more workloads, you just add more nodes, right? You just keep adding another node, another node, another node. So now what you can do is if you need more storage, you can add a storage node. If you need more compute, you can add a compute node. All right, let's get rid of these. So CML, thinking beyond ChatGPT, we like to say. So your data differentiates your AI. We want to enable our customers to build AI applications using their data within their four walls. So that's trusted AI and ML at scale. So how do you trust the accuracy of point-in-time data? It's your data that's in your data lakehouse that you're building these applications off of. We don't have access to your models. We don't have access to your data. It's all yours, and you do what you want to do with the platform. So LLMs, so traditional AI, you'd have specific training data sets, and then AI is built off of it. Now what we do have is training data and LLM. You feed up the enterprise context, and you get insights, the RAG-based model. So how does AI become relevant with data? So you can create a knowledge-based context that you pass up into your foundation model. So the first one is what we like to call a hallucinated response. So if you were to just go on ChatGPT and say, hey, where is SuzeCon, for example, it's not going to know, right? It's not going to know the current year unless that data has been accurate. So what you can do if you're trying to build your own chat box or whatever AI application you want to build, you want to pass in your own enterprise context data. So this is probably my favorite example. What is Iceberg? So for those of you that are not familiar with Apache Iceberg is a big part of our data warehousing portfolio, but it's a data warehouse system that provides table format that works just like a SQL table, right? But if you just asked OpenAI what is iceberg is going to literally talk to you about what an iceberg is, right, in the literal context. Our solution, it's really simple. Our customers find it highly effective. We have end-to-end AI ML, we have ML ops and development. It's secure and governed, and it's all Kubernetes, so it's completely cloud native. We also have a public cloud offering, so any application that you build in the private cloud, you can just take and go run in public cloud. So data engineering pipelines, data science, model trainings, just what does the integrated lifecycle look like? And this is our overall tech stack. So you can see at the top, you can create and build the foundation LLMs. That's using Cloudera machine learning, which is our AI ML platform. You monetize those endpoints if you wish, host models and applications. For AI storage, we offer different vector DB integrations. It's completely up to you. If you want the free versions, you can use Milvus and Chroma. The example that I'm going to show you today uses Milvus. For hardware acceleration, we have NVIDIA. And then for Open Data Lakehouse, we have Spark, Machine Learning, Ray, SDX, and NiFi. So we use NVIDIA everywhere throughout our entire MLOps and AIOps lifecycle. So you can see it in data engineering. That's NVIDIA Rapids. We have NeMo Retriever for data science, and then NVIDIA NIM for AI inference. I'll walk you through this demo on how we would build a chat box. I don't have time to speak. So this is what we call our AMP catalog. So it's our accelerators for ML projects. This is available to the customer right out of the box once you deploy the platform and you deploy the service. So here we're going to create a chat box. You can see the tech stack we're using here. It's an LLM chat box augmented with enterprise data. So you can pick your editor. We have Workbench. We have Jupyter. Pick the kernel you want to use. So in this case, we're going to use Python 3.9. We have an NVIDIA GPU, and then we're going to pick the specific version that we want as well. So there's multiple steps here, and these steps is how we launch this AMP. So the first step, making sure you have GPUs, and then all the way down, we're populating the vector database with document embedding. So in this case, what we're taking is our machine learning docs on our Cloudera documentation website, and we're creating a chat box where our customers can just ask the chat box questions about the docs, right? So we ingest all of those documents into our vector database using jobs. So we have two jobs here. We have populated vector database with document embeddings, and then downloading the models. So if your data changes, you can run these jobs at any time. You can run them on a schedule. Like let's say I go make an update to the website, and I want to populate my vector database with the document embedding, so I can run that. So this is what the job looks like. This is what the data looks like, and you can see it's completely unstructured. There's a lot of spaces, punctuation that's kind of all over the place, and that's really the best part about a vector database, so you can throw it all in. And we use Hugging Face behind the scenes for our sentence transformations and other ML items. So yeah, you can see there's massive space there. So the job downloads all of these website data and dumps it into the data folder. And that's this part right here. So you can see that the LLM model repo there, see the Hugging Face link. You can check it out. It's public. And you can see that we are using sentence transformers. And just, this is what the overall Hugging Face project looks like. So we'll go back to our, populating vector DB. It's a Python script that we run. And this Python script, what it does is we have a document embedding for each individual subtree. So if you took, let's say you have think of an XML tree, and you would have the top layer, this is CML, Cloudera Machine Learning, and then how do you set up Cloudera Machine Learning? How do you optimize CML? How do you configure it? Those would all be subtrees of the original XML. So we create a different document embedding for each individual subtree, and then that gets fed into our vector database. And you can see that right here, where it's talking about the ID path. You can see that we are inserting into our Milvus vector database. Collection name you can change to whatever you want, and it goes into our docs data directory. And at the end, it'll show you, this is how many embeddings we have. In this case, we have 13 subsections of the machine learning docs, which you will see later. And that's the job that you're running, which is, we talked about, it's populating the vector database. So you can run this on a schedule. If you know your website changes on, X frequency, you can run it on that. It's a cron job. You would just configure the cron with what you want to run it on. So this is a sample run. You can see that it took product overview, ML architecture. You see there's 13. So now we'll show you the actual application. As it feeds everything in. So you also have access to open it here, and then if you had multiple applications configured, you'd have it up here. If you click CML LLM chat box, you have some sample questions there. I guess the text is a little small, but what are iceberg tables? How do data scientists use CML? What are ML runtimes, and what kind of users run on CML? So that's basically the end of this. If you guys have more questions about this, I'm happy to go through it in more detail. We also have a SQL natural language processing demo. And it's just basically we have a natural language processing assistant that uses an LLM, and it will help you create your SQLs, optimize your SQLs, and things like that. So I'll just run through this quickly. So if you're a SQL developer, you might have a ton of SQL knowledge, but you might not. But if you had a SQL AI assistant that was working with you to, analyze the tables, views, structures, right, the rows, columns, all of that, and if it could feed into the entire database that you're working with, that's really powerful, right? You don't have to know how to do order, partitions, selects, froms, left joins, inner joins, just all kinds of stuff depending on the specific language you're using. So we've seen a lot of our customers take advantage of this. So we have two unique SQL engines, which are Hive and Impala. And the developer uses the AI assistant to, you can use it to create queries. So you can just, let me actually full screen this, sorry. There's a blue dot at the top, so you don't always have to have it on. If you'd like to have it on, you can. So you can generate, and you don't even have to put in the actual table that you want to use or anything like that. You can just say, like, for example, get store name, store ID, manager, zip code, total sales of the store. And it will actually go through all of the tables in that database, figure out which columns, rows are relevant, and compose a query for you. Now let's say you want to add another row or another parameter that you want to get. You don't have to start completely from scratch. You can hit edit and then just say, hey, I also want to collect statistics on this specific table. And it'll give you another thing. It'll show you the additions similar to if you were pushing up edits in GitHub. It shows you what it's adding or deleting. You can insert that in. You can also explain if somebody gives you a query that you have no idea what it does, which is very common, right? We inherit code when people leave, and we have to figure it out. We have to troubleshoot. We have to own it. All things nobody wants to do, but it does happen, right? So you can paste it in, hit explain, and it'll actually give you a summary of what it does. It could comment it for you, and it gives you a detailed explanation of the specific rows and columns that it's actually looking at. You can insert it. You can also optimize. That's really the name of the game, right? We want to be able to optimize, specific to the query editor that you're using. You want to make sure you're taking advantage of the latest and greatest features that that query editor or that query engine might have released. So you can fix your query, optimize your query, create a query, edit a query, and that's basically everything that this thing does. We find that customers really do like this technology, and this is specific to our BI tool. So if you use Hue, you can analyze your entire database and get exactly what you need. So I'll do a quick walkthrough of our data warehousing solution, which we call Cloudera Data Warehousing. This is built on Kubernetes as well, so you have fast self-service data exploration. You can do cross-team collaboration, analytical automation. You do get isolation and multi-tenancy. You can accelerate deployment cycles, and like we talked about earlier, you decouple storage and compute. They're cloud-native solutions, so anything you develop on Kubernetes with our platform, like I said, we also have a public cloud data services offering, which is the exact same look and feel. So you can take what you've developed on-prem, go run it in the public cloud. Query placement logic is just how our query engine works on Kubernetes. So we have two, right? We talked about earlier. So you have Hive, you have Impala, you have Hive Server 2, Query Coordinator, and Query Executor. Those are just the components of Hive. And then for Impala, we have coordinators, executors, and then executor groups. Elasticity of... So we have 3 virtual warehouses here and 3 ways to do auto-scaling. So we have wait time, headroom, and query isolation. So I'll show you guys wait time and headroom in this demo. Headroom is like if you have a specific virtual warehouse, you're saying, I need 1 coordinator and 1 executor up and running at all times. Wait time is, okay, so I don't have enough resources in this specific virtual warehouse, which is what we call our SQL engine, right? So if I say, okay, you need to run a query, he needs to run a query, but how long do you wait before I add more compute? And that's what I'm going to show here, right? So the wait time base fluctuating, so it's spinning up right now. You can see that all of them are 12 CPUs. It's up and running. And query isolation is if you took a specific query, you wanted to isolate it. If you had specific SLA needs for something. So I'm using this, so I can show you I'm connected to the namespace here. This is headroom, so I'm launching 1 query here, and then I'm launching another query, and a 3rd query, right? And the 3rd query is where we're going to run out of compute. So you'll actually see a whole new coordinator and executive group spin up. And you can see them right here, the ones in red. Those are the new ones spinning up. And that's headroom based. Wait time kind of operates in the same way. It just waits the predetermined amount of seconds, so in this case 30 seconds, and if there are no resources available in 30 seconds, it'll spin up a new one. And you can see you got results here for all of them. And I'll skip headroom, it's the same thing. Last data service that we have as part of our stack is Cloudera Data Engineering. Okay, so we have a containerized managed Spark service. We use Airflow for orchestration, which is another open source tool. Tuning and visual troubleshooting, simplified job management, and APIs. So we have pipeline orchestration with Airflow and CDE as a whole. So we pre-process the data, you have quality control, you can transform the data, create a data mart, you can train your model, calibration, and then save your predictions. So Airflow is the next-gen orchestration tool that Cloudera is using. Back by Airflow. You can also deploy custom DAGs, which are just, these are pipelines as Python code is called as a DAG. And you can do things like, run Spark jobs, you can run queries, all part of the same orchestration engine. And the best part of this is you don't really need to know how to code, or for the people that are not super tech savvy but still are data engineers. It's drag and drop. You can say, I want to run this query. I want to load this Spark job to do this streaming job. We have things like making sure your directory is not empty. So yeah, that's kind of how it works. Thank you. So I'll take any questions that you guys have.